Okay, so what I'd like you to do is just take a second and if you would do the first derivative and the second derivative sign chart. So pause the video, and this is on page 8, I believe, and it's number 7. And then when you're done, unpause. Okay, so this is what you should have for your first derivative and your second derivative sign chart. Okay, so just be careful of a couple of things. So we do have a closed interval here, so I want to include that here. You can technically put them on here. It's not wrong to put a -5 here or a +5 here. For whatever reason, we tend, because they really don't affect anything in the second derivative, and I'll explain that in a minute. But we primarily put our endpoints on our first derivative sign chart. Okay, and just remember that when you're plugging in to see whether this is positive or negative, make sure you put it in the factored form. It's just easier. All right, so now take a second and read the directions on page 6 for this entire page. So you have to find when we're increasing, decreasing, mins and maxes, and then concavity and points of inflection. Okay, so pause the video, work that out, and then unpause and see how you did. Okay, and here are your answers for part A, B, C, D, and E. So just make sure that when you're doing your, what were we doing here? I think it was when is it increasing? You're going to use -5 as one of your ends here. We never include the actual number itself, so that's why we use parentheses here, and the same thing here as well. Okay, here's your decreasing. Now, just as a reminder, so I wrote these down so that you could see them. So clearly this is a max because the function goes from increasing to decreasing. Just like 1 is a min because the function goes from decreasing to increasing. Then remember what we talked about. So let's just look here. If the function goes from decreasing to increasing, that would make this 5 going higher and higher and higher. So this would be then a max. And the same thing here, your function is going from increasing to decreasing, which gives you the max here. But if we're increasing, that means we started from a low point, which would make this a min. Now the cheater way of doing this, very simple. I would find these guys here because that's what you're more used to, right? A plus to a minus in the derivative means you've got a maximum in the actual function. And a minus to a plus in the derivative means you have a minimum in the actual function. Once you get these guys, I don't even really think about it. I'm like, oh, they've got to alternate. So if I go max, min, then the next one has to be a max. And likewise, if I have min, max, then the next one has to be a min. You'll never have a min with another min next to it or a max with another max. So that's one way to do it. All right, now when it comes to the concavity, just try to make sure that you're not using negative or positive infinity because we do have endpoints here, but I know that this has brackets. Again, we don't use the brackets. We're just always going to use the parentheses. Okay, and our point of inflection is where you just have a sign change in your second derivative. So there we go. Okay, so number 7 was pretty straightforward. Number 8 is going to be maybe, I don't know, a little bit trickier. I'm not really sure. So what I want you to do is, why don't you try taking the first derivative, doing the sign chart, the second derivative, doing a sign chart. Stop the video, try it, and then unpause and see how you did. Okay, so here we go. So just be a little careful when you get to this. So you're supposed to do chain rules. So you take this exponent 3, you drop it in front, and then you reduce this exponent by 1. Then technically, remember, you're supposed to multiply by the derivative of the inside, but the derivative of the inside is just a 1. Okay, so the easiest way to tackle this is to just take this, drop it down, and obviously that cancels out. And then just take this, including that exponent of 2, and drop it down. Now remember, to get rid of a squared, you would just take the square root. So then that will cancel out the square and the square root, so that's why the x minus 3 is just x minus 3. And the square root of 0 is 0, and here we go. Okay, and then there's the sign chart. Put your endpoints on there. Okay, first derivative, so I took the derivative of this. So I did chain rule again. 2 times 3 is 6, x minus 3, and then that becomes to the first power. Okay, all right, so I did the same thing, and there we go, and there's my sign charts. Okay, so why don't you pause and answer A, B, C, D, and E before I get moving. This is supposed to be a plus, my fault. So you should have a plus and a plus. Here are your answers. Okay, now just one little thing here. When we're trying to figure out the maxes and the mins, remember, if the derivative is always positive, that means the function is always increasing. It's always going up. So we're starting at a low here. That's why x equals 0 is a min. And then we're continually increasing, 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 which makes 6 a maximum. So for number 9, this one's going to be a little bit trickier. So why don't you take a moment and at least just take the first derivative and the second derivative, and then pause, and then put the video back on. So here's your first and your second derivative. Just make sure you got that. So the 2/3 drops down in front. We reduce this by 3/3. That's how I got this. And then we got this. Now, if I were you, don't do anything to this yet. Go take this now, take its derivative. So this times this is -2/9. And then I reduce this by 3/3. So that's how I got -4/3. Okay. So here we go. This makes this a little bit trickier. So I think the easiest way to start with this one is let's rearrange this first derivative to make it look a little prettier, I guess. So I know I have a negative exponent, so I know that that's going to drop to the bottom. So what I'm going to do is I'm going to keep the 2 up here. I'm going to bring the 3 down here. And then I know power over root, I have the cube root of x minus 1. Okay? All right. While we're at it, why don't we do the same exact thing with the second derivative? If you want to pause me and try it, pause me and try it. That's actually a good idea. Try to do what we just did in the first derivative with the second derivative. That's what you should have. So now remember, you're going to have critical points at endpoints. Oops, I thought I had my pointer on there. At endpoints of your interval, and where the derivative is equal to 0, which we can't, because remember I said to you, derivative will equal 0 when the numerator equals 0, but we have no x value in either of these. However, we would also have a critical point where the denominator is 0. In other words, the derivative or the second derivative would be undefined. Now, try to think of this logically. I think it might be easier. 3 is a number. We need to make this whole thing 0, which means what's under here has to be 0. So the only number that you could put in here and get 0 would be 1. So there's your critical point. So you don't have to really do a lot of math. You just have to do a little bit of thinking. So when you're doing your sign chart, here's f prime. We're going to put in our -2 and our 2. And now we're going to put x equals 1 in there. Okay? And when we come over here, we're going to do the same thing when we're doing our sign chart. Okay, let's look at the same thing. We need to get 0 down here, and that would be if we put x equals 1 right there. Okay, so 1. And again, just remember, I tend not to use these endpoints here, but you can. It's not wrong if you put them there. All right, so why don't you take a minute and see if you can put in test points and see if you can get your signs. Might be quite tricky. Not so tricky here. So maybe you want to try this first. Now, actually, you know what? Forget it, Griffin. I'll just go over it with you. So I'm going to start with the easier one here first. You're going to have to take the cube root of something. To make our life easier, I would like this to become a 1, which means I'm going to choose x equals 2. Okay, which is good to choose. Now watch, this is why. 2 minus 1 is 1. 1 to the 4th power is 1. The cube root of 1 is 1. Times 9 is 9. And then I have a negative number. Do you see that? So I try to pick something here that will make the math that I need to do a little bit easier. Okay, so I'm going to put a negative here. Now, let's say I am looking over here now. Okay, I could choose 0. So let's try 0. If I put 0 in here, I get -1. But -1 when I raise it to the 4th power is a positive 1. Cube root is positive, times 9 is positive, and then we've got that. Okay, so again, I'm going to have another negative there as well. Okay, so you just want to be a little careful when you're picking numbers because what you're putting it into is going to be a little bit tricky. Okay, now let's go back to the first derivative. So let's say I am going to try to find out what this sign is going to be. So I would pick 0, right? So if I put 0 in here, 0 minus 1 is a -1, right? If you take the cube root of a negative number, you will end up with a negative number, okay? So this whole thing right now is negative, times that 3 is negative, and then I've got a positive over a negative. And a positive over a negative would give me a negative. All right, so then let's look at the next one. So over here, now, we're going to choose 1.5. Don't worry about it. We don't need to know the numerical value. We just need to know, excuse me, we just need to know whether it's positive or negative. So 1.5 minus 1 is a positive number. And then the cube root of a positive number is a positive number, times another positive number is a positive. And then a positive over a positive would make a positive. I hope that makes sense. Okay, all right, now you answer part A through E based upon what we have right here. All right, so if we look at this, we are increasing from 1 to 2, decreasing from -2 to 1. Now, so I wrote these in red. This I know is a minimum because my function goes from decreasing to increasing. So if that's a min, remember we have to alternate. That's got to be a max. And this would also have to be a max. And again, if you really want to think about it, the function's coming from up here and it's going down and then it's going back up. So that's why this is a max and that's a max. I just shortened it, row plus or minus. You can write x equals 2 and x equals -2. All right, I am never concave up. I am always concave down, so that's from -2 to 2. And there are no points of inflection. POI, I just abbreviate points of inflection. Okay, so this is going to be a fun one. So this one, I am going to write f of x equals x plus x to the negative first power before I take the derivative. I don't want to deal with this fraction, okay? I could do quotient rule if you want, but I think it's a little more drawn out. It's easier to just bring this up. Remember, it's to the first, so you bring it up, it becomes negative. Okay, so why don't you take a second? Why don't you take the first derivative and the second derivative and just write those down? So just pause the video and do that. This is what you should have. I'm going to go one extra step with this, and I am going to rewrite this as 1 minus 1 over x squared. And over here, I am going to go one extra step, and I'm going to write this as 2 over x cubed. Okay, so basically we take it out of fraction form, so it's easier to take the derivative. But once we have the derivative, it'll be easier to find your maxes and mins and all of that stuff if you put it back into fraction form. Okay, so I'm going to go a little backwards here, and I'm going to start with the second derivative because it's easier. All right, so if I want to make a second derivative sign chart, I would look at that and I would say to myself, all right, well, I have endpoints of an interval, -4 and 4, but remember for the second derivative, we don't tend to put them on the sign chart, but you can. Okay, now here's where I'm going to repeat myself, and I know you know this already. If you have, this is the second derivative. Remember I said to you, if the numerator is a number, like doesn't have a variable, then this can't equal 0. Okay, now I'm going to sort of go back on my word when I get down over here, but that's a whole nother story. Because if you look here, this is one fraction, or one term, I should say, right? One term. But over here, we have 2 terms. So this still holds. We can't set the numerator equal to 0. But over here, we're going to have a bit of a interesting scenario. So let's just stick with, okay, so then what's going to make this equal 0? And only if you plug in x equals 0 would you have the denominator equal to 0, okay? All right, and so then from there, you can go ahead and you can plug in, let's say, -1 and +1, and you should end up with a negative and a positive, okay? All right, so let's go back to the left side, which would be the first derivative here. Okay, so because you have two terms, it's not going to be like this. Remember I told you, let me back up. We have critical points at the endpoints of an interval where the derivative is equal to 0, which this was not because of this numerator, and where the derivative is undefined, or doesn't exist, I should say, which is down here at x equals 0. So if we look at this, we know x equals 0 is going to be a critical point because that's the only number I can put in here and get 0 in that denominator. So put that off to the side for a second. Remember, x equals 0 is a critical point, okay? So is -4 and +4, but we're going to put that to the side. If you have two terms after you've taken the derivative, remember the other way to determine a critical point is setting the derivative equal to 0. We can actually do that when we have two terms. We can't when there's one. All right, so here we go. So I'm going to set this equal to 0. And essentially what I'm going to do is I'm going to add over the 1 over x squared, and I'm going to add it over here as well. Okay, like good old-fashioned algebra. So that's going to cross this out. So then I'm going to have 1 equals 1 over x squared. See what I did? Okay, and then all I'm going to do here is I'm going to cross multiply this. So if I cross multiply here, I'm going to get x squared equals, and if I cross multiply here, I get 1. Okay, and now to find x, I'm going to take the square root, but you have to be very careful. Remember, when you take the square root, you need a plus or minus. Okay, so then I have x equals plus or minus 1. So my sign chart's going to have a lot going on here. I'm going to have the -4 and the 4. Okay, I'm going to have a -1 and a +1, and don't forget that 0. Okay, that 0 comes from looking right here and saying, oh, how can this derivative be, how does it not exist when the denominator equals 0? And that would be this value right here. Okay, all right, so then this I'm going to label f prime. Okay, so now if I were you, when you're trying to figure out what these signs are going to be, probably your best bet, the easiest thing, would be to plug it back in here. Okay, so I'll do one with you and then you're going to do the rest. All right, so let's say I pick -2. So if I put -2 in here, -2 squared is +4. So that makes this 1/4, right? 1 minus 1/4. Is that a positive number or is that a negative number? So then that would be a positive. Okay, so why don't you pause and try the rest of them and see how you do. Okay, now I'm going to actually interrupt you right here. The only thing you can really pick, I would say, would be -1/2. So I want to just do the math with this, for that rather, with you. So you have 1 minus 1 over 1/2, that quantity squared, right? So that ends up being 1 minus 1 over 1/4. Do you remember keep, change, flip? So this ends up being 1 times 4 over 1. Okay, so it's really 4. So 1 minus 4. And if you look at that, that ends up being a negative number. Okay, you're going to do the same thing when you get here. So you're going to use a +1/2. Okay, and I apologize. I was supposed to use a -1/2. Not that that's really going to matter. Here, I'll put the negative in right here, because when I square that, it's going to end up being you know, a positive here anyway. All right, so then when you get to trying to figure out what the sign will be here, we're going to put in a positive a half. Well, if you put a positive half in here, remember that's 1/4, right? Which is kind of what you have right here. So then I'm going to have 1 over 1/4, which is keep, change, flip. And then I should still have a negative number there. So this would be negative. And now it should be a little bit easier when you're plugging in something here. So let's say I plug in 2. 2 squared is 4. So we're doing 1 minus 1/4. And that should be a positive number. Hope that makes sense. Okay, all right, and now do part A through E. So pause me and do that. Here are your answers. Okay, so if you want to pause and just check them, and then we'll move on to the next question. So you're going to turn to page 24. We're looking at number 12. This one's a little bit different. Easier in some ways, different in others though. So they give you whoops, let me just undo that. They give you a function, but they don't tell you what the equation is. Okay, and they give you this interval. So we know we've got endpoints at -3 and 3. This, for our purposes, isn't going to matter much right now. It probably will, you know, when you take your calculus in the fall, but we're not going to worry about it for right now. Okay, so we have this chart, and instead, like I said, they didn't give us a function, but what they did was they gave us a table of values, or a table, and they're telling us what everything is at certain points in time. So it says, what are the x coordinates for the absolute maximum and absolute minimum points on the function? Okay, so they want maxes and mins. I know that has to do with my first derivative. So I want to make a first derivative sign chart. So what I'm going to start by doing is I'm going to then, oops. So I made a sign chart and I just use these endpoints. Okay, now I'm going to read from left to right because I'm doing a sign chart for the derivative. I'm going to read here. So between -3 and -1, it's positive. So what that means, oh wait, and then back up. And then it says at x equals -1, it fails to exist. That means DNE, which means this x equals -1 is a critical point. Okay, so I'm going to put my -1 there. And as it says right here, I am positive between -3 and -1. And again, -1 is a critical point because it fails to exist there. Right, now let's look at what happens. Between -1 and +1, now the derivative is negative. So I'm going to have a minus sign here, but look at what happens at x equals 1. The derivative is 0, so that's another critical point. If the derivative fails to exist, or the derivative is 0, that means that those are points that go on our sign chart. So I'm going to put a +1 here. And because this says it's negative between -1 and 1, I'm going to have a negative there. And then look at what happens between +1 and 3. It's still negative. So that means all you're going to do is just put a negative there. And that's it. Okay. Now, why don't you pause me? Try to do the second derivative sign chart. Okay? That's what you should have for the second derivative. Alrighty. Now I'm going to change part A a little bit because we really haven't talked about absolute maximum and absolute minimum points. So we're going to pretend they don't. They are definitely very important, but I think that, you know, for what we're doing, it's just best off if we just kind of stick with the basics. So let's find any maximums or minimums. So if I look at the first derivative, right, max and min is the first derivative, I see I have a max here. Now look carefully. There's no sign. Oops. There is no sign change here. So that's nothing, just continues decreasing. That means that this at x equals +3, we have a min, which then means this is also a min. Okay. All right. So then for part A, it's asking for the max. So we have a max. Oops, max sorry, at x equals -1, and we have a min at x equals positive and -3. Okay, all right, look at part B. It says, what are the x coordinates of all points of inflection? Well, remember, to have a point of inflection, you have to have a sign change. And the only sign change I have is right here at x equals 1, not here. There's no sign change here. We're not going from a positive to a negative or a negative to a positive. So your point of inflection is at x equals 1, and that's it. Okay. Now, I would like you to try to take a minute and see if you can graph this function and see what it looks like. Okay, remember how I said what I would probably suggest that you do is we know we're going from -3 to +3. So -3, -2, -1, 1, 2, 3. And then just go one interval at a time, okay, and see how you do. Right, and so this is what your picture should look like. Okay, so I am increasing, concave up, all the way from -3 to -1. So increasing concave up all the way there. Now you could have gone from -3 to -2 and then realized, oh, I'm going to keep going doing the same thing. So that's also okay. Now you could go from -1 to 0, or you can just go from -1 to 1 because these happen to be the same. But I did look, you'll see. So -1 to 0, I said, okay, it's decreasing, concave up. So I went decreasing, concave up. You can see a tiny little dot there. And then I went from 0 to 1. And I know 0 is in here, so I'm still decreasing. And I know 0 is in here, so I'm still concave up. So then I just kept going. And then for the rest of the graph, I'm decreasing, concave down. So like that. Now, you may be a little bit higher than me. This might come down below the x-axis. That doesn't matter. But you just need to be increasing, and your concavity has to be the same as mine. That's all. All right, so just like the last one on the previous page, so we're on page 25 now, I am going to ignore certain things about this question because they're just things that we really haven't discussed. And that's something that you'll get more in depth with when you get into school in the fall. Okay, so if you read the first sentence, it says, let f be a function that is even. We're going to ignore that. It's really important to this question, but I want you to just get the basics down. So we don't need that for right now. So, and then it says in part A, find the x coordinate of each point at which we attain. Again, I'm not going to deal with absolutes, maxes or mins. I'm not going to do either of those. Okay. And I'm just reading, and I think that's it. So why don't you pause? So basically what's going to happen, Griffin, is we're not going to really even look at this because that pertains to the things that I just crossed out. Okay, so I want you to do what we did on the last question, and why don't you make a first derivative sign chart and a second derivative sign chart. So just pause me and try it. Okay, so this is what you should have. So remember, if you have a value that's undefined, that means they go on the sign chart. Okay, those are critical points. Then if you also have a value that's 0, those also go on the sign charts. And then again here, 2 is undefined, so those also go on the sign charts. And then because we had an endpoint here, I put it at the end here. Okay, all right, so why don't you pause and answer part A and part B. Just find the maxes, the mins, and the point of inflection. That's all they were asking for. All right, and there is your answer for the maxes and the mins for part A, and then your point of inflection for part B. Okay, so why don't you try part C? So pause the video and try to draw a sketch. Okay, and that's what your picture should look like. And if you notice right here, remember, if you have a peak or a cusp at a particular point, that means the derivative will not exist. And look, at x equals 2, the derivative and the second derivative doesn't exist. Now, it also doesn't exist here, right? So you might be asking, well, how come there's no peak or cusp here? Well, there actually is, but that's where that word even comes into play, and we ignored that. What ends an even function just basically means you're going to take this and you would reflect it in the y-axis. So if I were to mirror image this, what would end up happening is it would go like this, and then it would go like this, and then it would go like that, right? And don't worry, you don't need to write this down unless you want to, but then there's your peak or cusp, okay? Which would then, kind of substantiate that 0 is undefined. Okay? All right, so I'm on the last question, which is page 29. And what I want you to do is take the first derivative, the second derivative. And after you do that, then I want you to get both of those derivatives in fraction form so that we can find the critical points. So why don't you pause me and try that. Okay, so there's the first part. So check that out, make sure that you have that. If you do, now I want to take both of those derivatives and write them as fractions so I can figure out my critical points. So pause me if you did not work that part out yet. All right, so this is what I have right here. So the second derivative, because it's only one term, will be a little bit easier to deal with than if it's two terms. Remember, we did this on the last one, but I'm going to save the best for last. So I'm going to start over here. So just remember here, I can't set this equal to 0 because it's a constant. There's no variable there. However, I can figure out where this whole denominator would be 0, and that would be when x equals 0, right? Okay, and there's no endpoints if you read up here. So then if I want to go ahead and do my first derivative sign chart, second derivative sign chart, I know 0 is going to be on there. Okay, all right, I'm going to leave the rest up to you to determine the signs. Okay, all right, so why don't you pause me and try to figure out those signs. All right, so I would pick x equals positive 1, and I know if I take the fifth root of a positive 1 and then cube it, it's still positive. So this whole denominator will be positive, but that remains negative, so that's a negative. All right, so next I'm going to put in negative 1. But negative 1, if I raise it to the fifth power, is still a negative. And if I cube root it, it's still a negative. Anything with an odd power or root will keep it negative. If it's negative, that is. So I've got a negative 3 down here with a negative 4 up there. That will make that a positive. Okay. Now this first derivative over here on the left, remember, if you have two terms like we do here, you can set this equal to 0. However, I like to, before I do that, make a little side note. Oh, it's undefined when x equals 0, because by plugging in x equals 0, this whole denominator will end up being 0. So little side note, keep that off to the side. X equals 0 is going to go on our sign chart. Okay, so then that being said, I'm going to set this thing equal to 0, and I'm going to write 2 over the cube root of x squared, and I'm going to write equals 8, right? If I just add 8 and add 8. Okay, and then I'm going to put this thing over 1, and I'm going to cross multiply. So I'm going to get 8 times the cube root of x squared equals 2. Then I'm going to divide out the 8, and that gives me the cube root of x squared equals 1/4. Okay, so remember, another way of writing this is x to the power over root. And I like doing that because then I know the way I can get rid of that exponent of 2/3 is multiplying it by an exponent of 3/2. I just flip the exponent. So what I do to one side, I'm going to do to the other. So that will cancel that out. Isn't this fun? Okay, so then what that gives me is x equals. Now, remember that this is power over root. So I'm taking the square root of 1/4. So if I take the square root of 1/4, I get 1/2, right? The square root of 1 is 1, the square root of 4 is 2. Then I am going to cube that. Okay, so I took the square root of this, and then I'm going to cube that answer. And that ends up giving me 1/8. because u cube 1 cubed is 1, u cube 2. 2 times 2 times 2 is 8. Okay, wasn't that fun? Okay, so then remember we had 0, right? If we go back over here, this was D and E at x equals 0. Okay, and now we also have 1/8. This is going to be a blast. F prime. All right, so I boxed off in red up here where I want to put in test points. Okay, so I would definitely want to put them in here. It'll be easier. So like, for example, I'm going to use -1. So if I put in a -1 here and I square it, it becomes +1, right? And then the cube root of +1 is positive. So I've got 2 over 1, which is 2. And then 2 minus 8 is a negative number. So there we go, negative number there. Okay, now I have to correct something here, Griffin. So I am going to erase this here, and here's why. You know how here, when we took the square root and we got 1/2, technically when we take a square root, aren't we supposed to have a plus or minus here? Okay, so when you take a square root, I really should have had, and it should go in the parentheses, I just can't fit it, a plus or minus. So this should be a plus or minus, which means then my sign chart here should have a -1/8. Okay, all right, isn't that fun? All right, so now, as I was saying, we're going to pick -1, and when we did that, we ended up with 2 minus 8, which is a -6, right? So this would be a negative. All right, this is where it gets really tricky, is right in here. We are going to be taking the cube root of something, okay? It's dicey like this. I'm going to just come off to the side here. This is what I like to do. I like to rewrite that f prime of x as this, 2 over the cube root of x, and then I'm going to square that answer. Okay, just so you realize, this and this are the same thing. It's just to do the math without a calculator, it will be easier to write it this way as opposed to this way. All right, and then I don't want to forget that -8. All right, so this is why I'm doing this. I have to pick a number, and it's going to be a fraction, that's a perfect cube. Okay, so when I think of perfect cubes, like I know 2 times 2 times 2 is 8. So 8 is the perfect cube. So if I do 3 times 3 times 3, that's 27, right? So 27 is a perfect cube. So if in here, I could then pick -1 over 27. Now, I picked it because I know 1 is a perfect cube and I know 27 is a perfect cube. And I know that this number here is in this interval. If, remember, this is a larger denominator, but it actually makes this value smaller, but a smaller negative is actually bigger than this. I don't know if that just made sense. So it's kind of like -1/2 is in here because it's bigger than this. So this is also bigger than that. So I'm going to put in -1/27 right there. Okay, so you ready? If I take the cube root of -1/27, it's going to stay negative, but it'll end up being 1/3. Okay, because the cube root of 1 is 1 and the cube root of 27 is 3. So I'm going to write this math for you just so you can see it. So I'm going to have 2. And then we took the cube root of -1 over 27, and that's -1/3. And then we're going to square that. So that's going to be 2 over +1/9, right? Okay, so keep change flip. That's the same as 2 times 9, which is 18. And then I'm doing 18 minus 8, and 18 minus 8 is a positive number. Whoops. So that means this is a positive. Okay, now as if we were not having enough fun, we're going to do the same thing right in here. Okay, and I am going to choose the same exact thing except a positive. So I'm going to choose 1 over 27. All right, so I'm going to look at this and I'm going to just bring the work down here. Okay, so I'm doing 2 over, now I'm taking the cube root of 1 over 27, and that would be 1/3, and then I'm going to square that. So that's 2 over 1/9. Well, look, isn't that the same thing as what I have right here? So that's going to be 2 times 9, which is 18, and 18 minus 8 is going to be a positive number. Whew. Okay, and then lastly, we can just throw in 1 here. That's much easier. So the cube root of 1 is 1, square it is 1, this becomes a 2, 2 minus 8, that would be a negative number. And there we go. Wasn't that fun? Okay, now if you look at 16, it asks for the maxes, it asks for the mins, increasing, when's it concave down, we're not sketching. Okay, so why don't you pause me and see if you can fill out the rest of that. There are your answers there at the bottom right-hand corner of the screen in blue. Okay, so pause and check those out and see how you did. Okie dokie, see you next time.